So, hello everyone, my name is Elie and I'm currently working at Collabora. And right now I'm working on GPU virtualization. So I'm going to speak about virgl, like what is virgl, what did we do during that year working on that project, the infrastructure, and we are using GitLab quite a lot now. And also the evolution, because we are not finished working on that project and we are keep going on that. So first, virgl is a project for 3D acceleration in qemu. This project started with David Airlie 4 or 5 years ago, something like that. He wanted to have security and 3D acceleration in qemu, and it's based on Gallium. He chose to use that architecture because he knows about that, and it's still the best architecture for the virtualization. We did a talk. So Dave did a talk 5 years ago when he started that project. So it's this link if you want more details about the beginning of the project. Now, I think we reached the point where we can use that product, that software in a real product, and some company already integrate this project. qemu use it for a while now, so we are in very good shape. This is a small diagram of virgl in general. So in the guest, we have Mesa and his driver called virgl. There is a kernel part with virtual GPU. There is also the normal kernel graphics part, so KMS DRM. On the host side, we have qemu with virtual GPU and a software called Virglrenderer, which is going to convert the command from the guest to the host, and it will be available for your OpenGL driver on the host. So how does that work? So our application is written in OpenGL, and Mesa will interpret that and convert the GLSL to TGSI, and the virtual GPU will send that TGSI from the guest to the host, and the Virglrenderer part will translate the TGSI to GLSL, and your driver on your host will be able to consume that. David chose to use TGSI because it's easier to transfer than GLSL IR. We don't have to pass any objects. It's a simple way, but now we know that TGSI is not the best IR, so we are going to see that later. On the memory side, I'm not very familiar with that. I will just explain it very quickly. So the guest allocates some resources. The host will also allocate some resources. Then we are backing the memory, the guest and the host, and qemu create IO vects. So the guest will now able to write data in the resources, and if you want to transfer, you need to request that transferred. So qemu or Virglrenderer can copy the data from the host. So everything is now set up, and we can start the acceleration, the 3D acceleration. Last year, we were only able to run OpenGL 3 inside the VM, and we need a GL backend, so your system needs to run OpenGL. And right now, we are able to run OpenGL 4.3 and OpenGL ES 3.2 on the VM. And the backend, we have GL and GLES, but for GLES, we are stuck with SDL because we need to create a GLES context on our host. So all that code is currently upstream, so the qemu, Mesapart, Virglrenderer, everything is upstream, and you can use it if you want to. We run the CTS inside the VM, and we got the following results. So GLES2 is in very good shape because we don't have any failure. GLES3 is working well on GL backend, but on GLES backend, we still have 3 failure. These failure are only available, well, we can see that failure only on Radeon SI. On the Intel side, it's working well. I've got 0 failure on my system. And GLES2 on GL and GLES, we don't have any failure anymore, but there is a lot of not supporting tests due to the fact we don't implement some function and some extensions are missing. And we also discovered that when we randomize the CTS, so we run the test in a different order, we saw some state leaks and some tests no fail. So we are currently investigating on that. So how did we achieve all these results? So the primary work for us at Collabora is to enable the GLES backend. At the beginning, we didn't think about improving the GL support in the VM. So we need to find a way to expose GLES on the guest. So we are using capabilities when we launch the VM. So we say, all right, GLES is available on your host. I don't know, Desolation is available in the host, so you can generate shaders that contain Desolation or GLES. Also, when we generate in Virglrenderer, we generate shader, and this shader will be consumed by your driver in the host. So if your host is running GLES, you need to generate a GLES shader. So we modified the header in this case to add like the different header. And also, when we start working on that project, we generate only GL command. So for example, the shader contains GL draw buffer, and GL draw buffer is not available in GLES. So we are using GL draw buffers, and we say like we have only one buffer. So this one was very simple workaround, but there is lots and lots of workaround like this in the codes. And also another very big work was the format support. So there is a lot of format who are not supported in GL, but in GLES, sorry, but they are in GLES. So, for example, we emulate GL alpha with GL red. There is plenty of other examples. Also, debugging was very painful. So, when the CTS failed, you have to figure out why this test failed. So you have to look in your Mesa driver in the guest. It can be also like your kernel in the guest. We never touched the kernel, everything was perfect, so right. Now we can eliminate that, we think it's kind of okay. Is the copy between the host and the guests work correctly? It can be also an issue with Virglrenderer, which doesn't convert the TGSI to the GLSL correctly. And it can also be like QEMU or your host driver. So it's very hard, and we try to improve the debugging, adding more variables in the debug part of Virglrenderer, but it's still very hard to get something. If you want to create an API trace of qemu, it will be like hundreds of thousands of lines, and you need to find your shader inside and figure out what's happened. On the performance side, it's kind of correct. This is a test on Kabylake, so on my current system. There is some very big benchmark, like Engine Valley. On the host, I've got 31 FPS, and between brackets, it's the minimum and the maximum FPS we have. With qemu, we've got like 1 FPS, and it's like very stable. vtest is something we have in Virglrenderer that allows us to run GL application inside the VM without using qemu. We are using WebSocket to pass command between the host and the guest, and the performance are a bit better. Oh, by the way, all these results are with the GL backend and not the GL ES backend. And a very synthetical test, like GPU test, the performance are almost the same between the host and the guest. So I think that's good for us. And this is the thread when we spoke about performance. On the infrastructure part, we now move everything to GitLab. So the pull request and the report happen in GitLab. We are one of the first users, I think, for GitLab. And we still have some discussion happening on the mailing list or on IRC. And we are planning to add more features to GitLab, so we are working on a CI. But it's very hard to get a CI for Virglrenderer because there is a lot of components in the stack. So right now we have a known good version of Mesa, known good version on the DRM, no good version of the CTS. And we are running all these tests on top of LLVM pipes. It's still a discussion and it's still in progress, but we are able to run all the CTS, so GLES 2, 3, 3.1 in 15 minutes. So we will be able to add this feature, I think, and we are going to improve it later to have something more performant and be able to test everything on top of upstream. So, like I already spoke about the future, but one of the plans is like improving that CI. We still have some failure to fix, so few failure in CTS, in Piglit, so I'm mostly running the GL or quick GL, and I've got 3,000 failure. Most of them are due to the same error, so I think it will be quick to fix that. We need to improve the security because most of the people use virtualization in order to secure their system and their VM, because you can easily access memory with the graphics card, and you don't want the guest to access, I don't know, random pages on your system. So make sure we are very good. We have fuzzer in Virglrenderer, but it's mostly for the API and not for other part of the stack. And also we are working on coherent memory. So now we have a buffer in the guest and another one in the host, and we did a lot of memcopy. And the goal would be to have only one shared buffer between the host and the guest. Some people here know maybe a bit about that, quite a lot even. Also, we plan to add Vulkan support. Student Nathan start working on that. You can find his work on his GitHub page. Using Vulkan is quite nice because we can just send instead of sending TGSI from us to the guest and then convert the TGSI to the GLSL, we can just send SPIR-V. It will be also more secure because most of the conversion and work will happen in the guest, and then your system will just have to consume the SPIR-V, so you can't crash the VM because you missed something in the conversion between TGSI and GLSL. So it will be, I think, a good improvement. So, demo, I guess. All that presentation actually happened in the VM. So this is my VM, and I'm currently using the GLES backend. And my desktop is actually quite smooth. I can run a game. It's not the most demanding 3D game, but I found that right now, so I guess it's good enough, and I can just navigate and everything's fine. So, yeah. I'm not good at that game, so. Right. So, yeah, I've got absolutely no issue with the VM right now. I don't use like big game. I don't try very demanding 3D stuff because my system is not powerful enough. But with a biggest graphics card, I guess you can run every game. Well, not every game, but Doom can work, or Quake. So if you want to join, so we are using mostly GitLab right now, so you've got the link. We have virgl 3D on free desktop, on freenode, sorry, so IRC, but we prefer using the list, actually, the mailing list right now. So this is the mailing list, and I think that's it for me. So if you have any question, please.
You mentioned that doing Vulkan over virgl should be more secure than Glass, and I said, WTF? So as you're, maybe for the shader, sure, but as you're consuming the client's Vulkan commands and pushing them over to the host, if you just do your best to translate those Vulkan commands as directly as possible and then execute them in the most literal way as possible on the host side, you can't trust the client's Vulkan commands do not seg faults and crash. So what are your plans for preventing the host from crashing? Not the host system, but just the VM host.
So we just start working on Vulkan. We have a rough idea of what we can do. We can, for example, verify that the SPIR-V generate is valid and correct before sending to our hosts.
But you can't validate the Vulkan API command stream itself without destroying the purpose of Vulkan.
Yes.
So, okay. Maybe we should chat. I have some ideas. Okay.
Yeah,
Okay.
with pleasure.
Yeah, and with memory, we do probably have to work on the kernel side in the host to improve the VM and per context stuff, things like that. It's it's difficult, especially when you can basically read any pointer you want in the memory space. So you can essentially read any memory inside the memory space in Vulkan. So you can probably read other clients' memory if you can guess where they are on the host side. So there's some stuff that we need to figure out, and might then need to add some extensions to Vulkan on the host in order to make it safe.
So you made the claim at one point a couple slides ago that switching to SPUV is somehow more secure than TGSI. And I'm a little curious as to why you think that's the case.
Sorry. Can you repeat, please? I just don't.
I'm wondering why you think that SPUV is more secure in some way than TGSI.
It's more like we avoid the conversion between TGSI and JSL. We saw a lot of failure and crash because that conversion doesn't happen correctly. TGSI is like the buffer are untyped, and we need to convert and do a lot of casts for getting a typed buffer for JSL, and we have a lot of failure with that. We had failure with that, and we can avoid that with SPUV. So that's why I say it's more secure, but yeah, SPUV is also different for the memory point of view, so we can have failure with that or issue.
So the TGSI we send over is text, and then we parse that into TGSI bitcode and then turn that into YLSL text and then into. So there's a lot of text parsing going on and text emitting. And that code is but I don't know how better a SPVR validator will be, if that will also be or so.
Yeah, so posting SPUV probably is more reliable than posting text. I will grant that. But you are going to have to do some serious validation, and the validation is going to have to be probably more than what the current SPUV validators are doing, because I can point you to a number of bugs in the SPUV validators that cause various things to crash, and in your case, bring down the VM.
Yeah, so there's a lot of validation that needs to happen. Yeah, but yeah, you're in a VM, you're going to pay some kind of
It's still better than 3 OpenGL validators chained together.
Separate process.
Yeah.
This is a question
No, we know. But that's up to the people who are actually using virgl a little bit if you want to separate it on the processes. So, yeah. And also, a lot of these problems will go away if people actually did proper mediated pass-through. So.
Any other question? Okay, thank you very much.